Hi, it's Carly McAvoy. I wanted to show you how to use GeoGebra to solve some typical problems that you might see using Bernoulli trials. One of the things you might see is this notation, x and then a tilde sign, binomial NP. X stands for our random variable that represents the number of successes out of a certain number of trials. And the tilde is read as defined by. And then the binomial n comma p means we're using a binomial model with n number of trials and a probability of success given by the letter p. So I would read this up here as our number of successes is defined by a binomial model with n trials and a p probability of success. P is a probability of success. Remember, to get Q, we just take 1 minus P. That's the probability of failure. N is the number of trials, and X is the number of successes in N trials. I don't know why I have that in bold, but if you were going to find the expected value or the mean of this, you would use n times p, and the standard deviation, you would use the square root of npq. So they're not very difficult formulas, but you're going to find that GeoGebra does that for us. What I have done here is a picture of GeoGebra, and you can see over here they give you those two values right there. So you really never have to calculate that, but I'll show you how to do it in case you don't want to use GeoGebra to do this. This is a picture of a binomial model in GeoGebra. To get to that, we would go to GeoGebra.org/classic and then choose probability and then binomial. So I'm going to do that over here on the other side of the screen in a second. But that's what we're going to do as we answer these questions. Here's our example. Our free thrower is still making 82% of her baskets of her free throws. Assume each shot is independent of the last. She's going to shoot 10 free throws. So our n is 10. And our p is 0.82, and our q is 0.18 because 1 minus 0.82 would be 0.18. And so instead of writing n and p, we would actually fill in what our model is using, which n is our number of trials, and our probability of success is 82% or 0.82. So the question is, what is the probability that she would make exactly 5 free throws? So once you get over here, we're going to go to GeoGebra.org/classic, and then we're going to click on probability. Now what this is going to bring up is normal, which we don't want normal. So what we're going to do is scroll down to find binomial. Here it is. Now when we see binomial, we have these values up here, but we haven't entered our information yet. Our information is we have 10 trials, so instead of 20, we're going to enter 10, and then our probability of success is not 0.5, it's 0.82, so we would enter those values. And now we can start to use this model to answer our questions. When you're looking at the probability of making exactly 5 free throws, you can just use the numbers over here. This is the probability of getting 0 free throws, of getting 1, of getting 2, all the way up to getting 10. And so you can also see that we have this highlighted right now for 8, 9, and 10. We'll change that in a second. But if you just want to know one exact value, like 5, you can come right here and see that's going to be 0.0177. She's going to get exactly 5 free throws. We're just going to use the probability on the right-hand side. The probability that x is exactly equal to 5 is this, which if we move it 2 decimal places, we get 1.77%. The second one, what's the probability that she makes 9 or 10 free throws? Those are just two probabilities added together. So we would find out the probability of 9 and the probability of 10. And you can look over here and see the probability of 9 is 0.3017, and then the probability of 10 is 0.1374. And if you add those together, you get your probability that she will make 9 or 10. So there's a 43.91% chance she'll make 9 or 10 of the 10 free throws. Now here's where we're going to start to use these buttons down here, the probability that she makes at most 2 free throws. At most means she might make 0, she might make 1, or she might make 2, but that's the most she's going to do. So it's actually a less than that we're working at. And so we're talking about what's the probability that she makes at most 2. That looks like this. Whoops, we're here. X is less than or equal to 2. And you can see that the probability of that happening, of her getting 0, 1, or 2 when she's so good at her craft here. She's making 82% of her free throws. The probability that she would get less than 2 is 0%. You can see up here, if we add those all three together, it's still going to be 0. So the probability that she would get, is a 0% chance that she would make at most 2 out of 10 free throws. You can see up here, now our values are there for our expected value, or our mean and our standard deviation are showing there. Okay, what's the probability she makes at least 7? At least 7 means she might make 7, she might make 8, she might make 9, she might make 10. So we're talking about greater than in this case. And so we're looking at greater than 7. So we want to use the greater than, and then we get 0.9117 because we're adding up all of these. If she gets at least 7, she might get 7, 8, 9, or 10. If you add that all up, that's going to add up to a pretty certain thing. And so if I come back here, I'm looking at this, and then I can state that by moving my decimal point over 2 places, there's a 91.17% chance that she will score at least 7 free throws out of 10. All right, moving on, what's the probability that she makes between 6 and 8 free throws? This is all out of 10, given that she's going to do 10. Again, we're using the same model every time. Our probability here, we're going to look at this 2 scores in, we're going to look at in between. And what we're interested in is 6. We're using this button right here because we're in between 2 values, 6 and 8. And you can look at the graph and see they're looking at 6, 7, and 8. That's what they're talking about. You could add those 3 things up, but it does it for you already. Between 6 and 8 would be 0.5395. Once you know how to use the GeoGebra program to do this, you're really not having to do too much work, but making sure that you're entering those numbers correctly. And then that's just saying then that there's a 53.95% chance she'll score between 6 and 8 free throws. And finally, what's the expected number of baskets that she makes, and what's the standard deviation? We can go back to these values, and we're taking n times p. There's 10 times that 0.82, so that's going to be 8.2. You can see it's given right up here, and then the standard deviation is given by the square root of NPQ, and if you do that, n is 10, p is 0.82, and q is 0.18. Multiply that out, square root it, and you get 1.2149, which is given right here. So again, you can do that on your calculator using those 2 very simple formulas, or you can just use that on GeoGebra. I want to thank Julia Trude for writing these notes, and I just kind of copied her video on this. All right, have a fantastic day, and we'll see you next time.